And we're back. Microsoft Virtualization with Hyper-V and System Center. Corey Hines, Simon Perriman, bringing to you Module 11, Managing Clouds with Virtual Machine Manager. Now, before we jump straight into Module 11, we've got a couple of quick housekeeping items from the previous module. One of them being a question that came up rather frequently, which with regards to virtual machine migration.
Okay.
And so the question was essentially, hey, I want to do a VMware to Hyper-V migration. I don't have VMM yet, because we're kind of, we're in the evaluation phase.
Okay.
I want to take some of my VMs off VMware, throw them on Hyper-V, see how everything goes, see that I'm happy, and then if I am, start layering everything on top. Is there a way to do this without VMM?
There is actually. If we could switch over to my screen here, I'll actually show you what I'm going to pull up. This is the Microsoft Virtual Machine Converter, and you can find that one at aka.ms mvmc. So Microsoft Virtual Machine Converter. And basically this is a free download independent tool. I'll zoom in a little for you here. Giving you the ability to go and convert VMware VMs over to Hyper-V VMs. There are some limitations with this. It is not as fully functional as the VMM version. So if this actually doesn't kind of meet all your requirements that you need, here's the trick. Go download the evaluation version of Virtual Machine Manager. You have 180 days. Go use V2V from that. And you of course have to install it, use it, but that's how you could kind of use the better temporary version. But again, if you don't have this, you can go ahead and use the MVMC.
Okay.
Good question.
Fantastic. So with that, we'll move into managing clouds. One of my favorite topics, right? Which is, how can you take all this capacity and logically partition it amongst multiple users, multiple customers, and the term that the industry uses is tenants. And a tenant doesn't necessarily mean, you're a hoster and you have companies using your stuff. It could be departments in your organization. It could be administrators within your organization. It's just a way of taking that physical capacity, making it fundamentally invisible, and then allocating and partitioning logical capacity to different users.
Absolutely. Now, clouds, first of all, I guess let's kind of define what we're talking about with a cloud. It's a term that's thrown around quite a lot, right?
Didn't it used to be the internet at one point?
Right, yep. So being the most popular term in the world, we better define what exactly we mean by a cloud here. Functionally, it's going to be your pool of resources. And that's really just the best way to think about it. So anything within Virtual Machine Manager that you've added under management, that goes to part of your main cloud. So under storage, that includes your storage providers, iSCSI, file shares, Fiber Channel, so basically all those storage components. Under networking, it includes all the network resources like your load balancers, your profiles, ports, virtual templates. And then under the servers, that includes all of your physical hosts and your clusters, crossing all three hypervisors, VMware, Citrix, and Hyper-V. So that is what VMM calls its cloud. But what we're actually going to do within VMM is carve it up, break it up. Now, first of all, let's just quickly talk about other types of clouds we see here. Public cloud, private cloud, hybrid cloud. Now, a public cloud is what we refer to, in our case, as Windows Azure. It's basically a collection of resources that the public can consume. So think of that same model in VM, right? It's your aggregation of storage, networking, and compute resources. Azure's the same thing. It's just a really, really big aggregation of all these different resources. You then have the concept of a private cloud, which is what we're using inside VMM. Our cloud in VMM is our private cloud. It's the aggregation of resources that are your resources. And then finally, we're going to have what we call a hybrid cloud. And a hybrid cloud is where you're essentially sharing resources across both a public and a private cloud. And a little later in this chapter, we're going to take a look at using some public cloud resources and some hybrid cloud resources, as well as third-party hosted cloud resources. So virtualization in the cloud, where does it fit in? Well, as we've really thought about virtualization, a cloud requires more than just being virtualized. A couple of years ago, about 2 years ago, when we first started talking about the Microsoft cloud, people said, I have a virtualized environment. I have a cloud, right? Not quite. So we really want to kind of define where virtualization ends and where cloud begins. Because this is how we're trying to shift mindshare from just having a data center that's highly virtualized to having this fluid and dynamic data center. Now, virtualization absolutely is a critical part. It, of course, gives you our benefits of consolidation, easy deployment, elasticity and automation, having multiple tenants, and then high availability and mobility. But having a private cloud requires more. Pools of resources, automated management, self-service provisioning, and usage-based chargeback. This isn't Microsoft's definition. These 4 components actually come from the National Institutes of Standards and Technology, NIST, as their definition for what creates a cloud. And so you're going to see throughout this chapter that, throughout this module, that we're covering most of these key cloud tenants just with VMM. VMM is going to help us do automated management. It's going to allow us to pool all of our resources. It's going to allow us to do self-service through App Controller. The one thing that VMM will not offer is chargeback, but we could take advantage of chargeback by using System Center Service Manager. So it is included in the System Center suite, and it will actually, Service Manager will actually monitor the resources which VMM uses, but it's just exposed through Service Manager. So chargeback will be, should be out of scope for the exam. So here we go under VMM. You can see the management console here. You see clouds, which is the pool of resources. Below that are the subclouds. So how would we go about and actually break up a cloud? What are the different ways that you can take this pool of resources and carve it up? And in my opinion, we see people do this in a huge variety of ways, just like host groups. We see people build clouds based on VMware infrastructure, or based on Hyper-V infrastructure, based on what the actual physical servers are. We see people build clouds based on geography, based on project. But what the main difference is between a cloud and a host group is providing secure access for our end users. When we look at host groups, those only get managed by our actual infrastructure people, accessed by our infrastructure people. That shows that underlying physical hardware, the clusters, the networks, the storage. When we're building this level of cloud, we're abstracting it, and we're providing end users with access to the cloud. So again, functionally or organizationally, it can be managed the same way as a host group. Big difference is host group will relate to our infrastructure people and below. Clouds are generally going to relate it to our end users through self-service and above.
Now, one thing I'd like to inject in this conversation a little bit is when we talk about the idea of an end user, we're not talking about, Andy the accountant. We're talking about what oftentimes is an administrative user, right? A user who's responsible for creating objects within a virtualization infrastructure to serve business functions, not your everyday feet on the ground Salesforce and HR guys and all that kind of stuff. These are end users in the sense of users of the cloud that are defining objects and resources.
Yeah.
And those users are typically IT admin type folks in a company anyway.
A good example might be our SQL DBA, right? The SQL
Correct.
guy, he needs databases, he needs storage, he needs VMs, but he might not want to touch the clusters, the fabric, that underlying actual storage resource. He just needs, I need a VM which has SQL running in it so I can go create my new database.
Right, and he's an example of a user in the discussion around cloud.
Yep. Another one we commonly see are developers as well. One of the ways that we're trying to simplify agility in the data center is increasing the application lifecycle, meaning the handoff from developers with code down to the infrastructure guys that go and actually run that code. And so we have a lot of developers that are, using infrastructure time, saying, hey, I got my new version ready, I've compiled it, I want to go test it on one of our VMs. Well, what we want to do is provide them with self-service so they can go and request that VM. They can go request and provision their test environment, free up our time for this somewhat repetitive task. And so going back to those private cloud concepts, we have self-service, enabling an end user to make requests. And then we tie in automation, meaning we have a type of standard request. I need this VM based on this template. Push a button, it gets deployed automatically. So what you're kind of seeing now is we're really trying to move from just infrastructure management within this course to start talking about private cloud management and these key concepts of the pooled resources, self-service, and automation. Of course, chargeback's number 4, not on the exam. So as we look at our cloud resources, storage, network, memory, and compute. We also have the ability to use our library servers as well and include our databases, applications, other templates, physical hosts, and VMs. Now, an important concept of cloud when we start to think about self-service is defining capacity. So you have a particular user, let's say John the developer, and you have a group of users, which is the development team. What we can actually do is provide capacity maximums at both the individual level and his group level. So we could say John is limited to only deploying 10 VMs, but the entire developer group across the 10 of them can deploy up to 50 VMs. So we could put some control both on the individual and on the group level.
This is often called cloud shaping.
Cloud shaping, yep.
Is a term for it.
Now within that capacity as well, we could go and configure resources across 3 different hypervisors. We could deploy services to just one, to both, to multiple, assuming that those Hyper-V hosts will support that type of VM or application. Now, as we look at managing the cloud, we have things such as chargeback of our resources. Now, again, this is going to be exposed through Service Manager, but we go and collect the data in VMM. So if you go into Service Manager, take a look at that, go through the chargeback, you get to define a cost center, set up a price sheet for the price of a VM, price of a gigabyte of storage, a gigabyte of memory. And based on that pricing sheet, we'll then monitor VMM, figure out, hey, John the developer used 5 VMs, a VM costs $10 a day, John costs $50 a day, hence that's the amount of price that we would charge back. Now, chargeback in a private cloud, take a step back, chargeback in general. When we think about chargeback in a public cloud, it's pretty logical how that works, right? I'm Windows Azure, you have your own company, you use resources, you pay for those resources. But chargeback in a private cloud is often treated differently because we're the same team, right? Now, there are large organizations where they will actually cross-charge different business units. But in many cases, it's not so much chargeback that's interesting. It is showback, which is interesting. And showback's the same concept. It's saying, this is what you've used, this is how much it's costing us, this is what we need to invest to keep supporting you. Basically, this is the cost to us for running your business. That's okay, you don't have to pay for it. But what we're trying to do is show you the resources you're using so that you can hopefully make better decisions in how you go and build things for us. So it's really driving incentives of best practices using showback.
So who cost you the most data center dollars is what you're trying to figure out.
Exactly.
And it's not necessarily measured in dollars per se, in terms of measuring to scale to an economy. It's just a measure of relative to everybody else that's important.
That's right.
Showback.
And so, maybe you have one particular development team that's using like 50% of your data center resources, every other team's using 5%. That's something where you can go to a business manager, think about how are you guys doing it, and hopefully drive some best practices, lower utilization, free up some data center resources. Now, some other enhancements as well using some of the other System Center products is application performance monitoring. Now, application performance monitoring is a feature of Operations Manager that basically allows us to not just monitor the availability of an app, is it on or not, but also measure the performance of an app. How well is it running? And this goes back to this tighter integration with our developer community, building better DevOps. Basically, what APM allows us to do is actually test code that's running on our infrastructure and actually test it line by line, figuring out how long each piece of code takes to execute. Now, the reason why we want to do this is to kind of get past that finger pointing we were talking about earlier, right? An application is performing slow. Whose fault is that? Is it the infrastructure guys because he put it on a bad network? Is it the developer because he wrote an inefficient SQL query? Well, the whole goal behind APM is to eliminate this finger pointing, is to identify exactly how long every line of code is taking so we can have a better understanding of where that delay lies. Now, Global Service Monitoring, also known as GSM here, you're not going to need to know much details of this, maybe just what the name of the feature is. But GSM allows us to go and monitor your own apps from different data centers that Microsoft provides. So it's actually an Azure-based cloud, actually it's not an Azure-based service, it's a cloud-based service that runs in our Microsoft data centers. Now, effectively, what GSM does is it allows people to upload their own test cases. Those test cases can get distributed across Microsoft data centers, and we will go and test your app in your location from these different locations around the world. So how would this be useful? Well, let's say I'm a developer and I'm selling coffee because I'm from Seattle. That's what we do here. And I'm selling coffee and I have a local website. My development team's based in Seattle, and so I know how well my website works from people in Seattle. But what about my people from Brazil, from Japan, all around the world that want to go and actually access my website? Well, if they have a bad experience the first time they go, it's slow or unresponsive, they may never come back. I may lose my customers. And so what GSM does is it allows us to basically go and upload our tests for our website running in Seattle to these 16 locations around the world, and actually go and run custom web tests built in Visual Studio and send back performance data. So we could see, hey, things are working well in these locations, not so well in these locations. Oh, and here's the particular line of code that's being slow. So really trying to help you eliminate some of the problem-solving steps here as well.
I did get a chuckle that time. Seattle, right? It's three things: coffee, software, and airplanes.
There you go. So let's actually go through and jump over to our demo and take a look at building a cloud. All right, so back to our system here. Now, we build clouds under our VMs and services workspace. Now remember, even though a cloud is a collection of Fabric resources, this is something that we're exposing to our end users. So we're going to put this up in kind of our end user view, VMs and services. Now, under cloud, you get this default container. Well, we want to actually go and create our Contoso cloud here. Call this Contoso cloud. Within this cloud, we get to specify which physical hosts can be accessed in it. So let's go and select all of our hosts. And if you're adding a VMware collection of servers to the cloud, you can also add a VMware resource pool. What networks are going to be connected to this cloud? Which load balancers can be used with this cloud? Which VIP templates can be used with this cloud? Again, this is that virtual IP address that can be used with a load balancer. What port classifications can be used in this cloud? So do we want to make sure that all VMs deployed in this cloud have the iSCSI port classification? Well, we'll keep it flexible and not select any of these. Select the storage classifications available for this cloud. So we'll say that users of this cloud can access our bronze storage and our gold storage. But you know what? We're not going to give them access to local storage on any of our hosts. We don't want them affecting our parent partition. Then we get to go and specify actually what library resources are available for each cloud. And so let's say you do something based on geography. You create clouds based on different user locations. This is an example where you can help specify which users can access which libraries to make sure they are deploying from the one closest to their location. So I want my Seattle users to be using my Seattle library. So we can select the actual VM path, and we can even select individual shares that we want to access here.
So what you're doing here is picking all the objects in the infrastructure that you want this particular user to be able to see when they access this cloud. And it's only
That's
a
right.
subset. It's only the things you choose.
That is correct. And so next thing we're going to look at is our capacity. Now this goes back to these maximums we want to set. Now, since we're going to make this our main cloud, we're going to use the maximum for everything, except for memory. Now you can see across the different hosts I have a total of 16 gigs of memory. Kind of small, I know, just a demo environment.
Well, it's a really sunny day, so the clouds are small.
There you go. It's one of those rare ones we get in Redmond in November. Click Next. Actually, let me just take a step back. Take a look at the other things here. We have virtual CPUs, memory, storage, number of virtual machines to deploy. And then there's also this option called Custom Quota, based on points. Quota is actually a setting which you can go and configure yourself. Define it whatever it means to you. So maybe you have a special business need, and you have, let's say, widgets. I mean, very obscure example, but widgets is something which limits when you can deploy resources. Maybe it's number of free hours for a particular engineer. But essentially, you can go and create custom variables and still map those within the size of your cloud. So if you get asked a question on the exam, you're trying to set capacity for blah, and it's not a VM, storage, memory, or CPU, could be a question asking about quota points, and you'd say, hey, this has to be a custom resource. We're going to go and configure this as a quota point. And finally, which VM capability profiles are going to be used?
So by checking Hyper-V there, you're saying that this cloud's only going to deploy things on Hyper-V.
That's correct, yep. But we could select multiple, so
Absolutely.
you know what? Hey, let's just go select all three, if I had all three in my infrastructure. We could view our script, creating our clouds, click Finish, and now it's going to go build our cloud. Oh, I know what I did here. We need to go and edit our path. So what I actually did here, when I selected the path of our VMM library, it's not writable for this user role. So let me go back to my library here. Delete this, continue, continue, and we'll go create our cloud. And again, just to clarify what I did there, on that setting, it asked me for a writable share location, and I only had read-only share locations available, so that's why it popped up the error, so that I didn't accidentally misconfigure it when I started.
Great thing about VMM, though, is it does tell you things to that level of detail.
And gives you actual guidance on how to fix it too. So, you can kind of figure out things on the fly without having to look up KB articles, search online, things like that. So now if I go expand my clouds, check that out. I have my new cloud. Can take a look at the properties of the cloud. Same different configuration options that I have down here. Okay, so let's go back to our presentation, and now we'll start to talk about the different user roles. So first of all,
No, go ahead, sorry.
what user roles are available? Okay, so what is a user role here? Now, basically, a user role contains a collection of settings, and we apply that to a particular user, all built using Active Directory credentials here. So for a particular user role, you could say that they have access to particular profiles or templates, different members, what those users can do, access the network, other resources, other permissions.
So we had a question that actually came up in the chat window kind of regarding this, specifically asking, okay, if I want to go in and actually, I create the cloud, now I want to assign individual people access to the cloud, how's that done? And the user role is the way that that's done.
That's correct.
Now, important to clarify, the user role contains, as you mentioned, members, so it's not one account. It's not a shared account. It's a role that you can have multiple accounts to actually be a member of, and then within that, further constrain the cloud. So the cloud is a big set of, of parameters of RAM, CPU, disk, resources you're allowed to have access to. With the user roles, and you can have more than one user role in the same cloud, can constrain that a step further.
Yep.
So, for example, your developer cloud is allowed this much, and then within the developer cloud, the user roles are allowed a smaller slice of that as well.
Great point, great point. So what can somebody do within a cloud? Well, actions is a very important thing, limiting what people should or should not be doing in a cloud. Now, a good example of this is creating checkpoints. You have an end user or developer who might not be really familiar with what a checkpoint is. They just think it's this magic thing to let them save work. They might be clicking checkpoint every 2 minutes as if they're clicking save on a Word document. That's going to quickly balloon your disk drive and flood it, and you're going to run out of space soon. And once you run out of space for a virtual machine, it's going to shut down when it needs to grow. So limiting things like checkpoints for people that should not really be touching them, that's really important. And that's one of the advantages of cloud, to really control what people can or cannot do. Now, within the actual user roles, there's several different types of user role profiles. So first user role profile comes by default. This is going to be our administrator role for the virtual machine manager admin. Second type of user role is what we call a fabric administrator. It used to be called a delegated administrator.
So this is the guy that runs the data center, that knows how to talk to the storage, knows about the switches, knows about the file servers.
They understand the stack.
Yeah, and they're configuring things at the physical level, and they basically, they live in that fabric section of the VMM console.
Yep, that's correct. And they could have access to everything within
Absolutely.
VMM. The difference with the fabric administrator versus the main VMM administrator is that a fabric administrator can be scoped to the host group level. So if you're the Fabric guy, remember Fabric host group, that's one thing. Clouds end users, that's another group. So with our Fabric and host group, we can say that this particular administrator from the Seattle data center only has access to the Seattle host. My administrator from the Munich data center only has access to the Munich host. So this way we still have some ability to make sure people aren't interfering with other data centers. The third user role we have here is the read-only administrator. This essentially gives them access to any host, any set of host groups you want to give them to, but they can only perform read actions on it. They can't actually change anything. So this could be helpful for people that are troubleshooting, first-tier support, basically the people that are kind of doing the initial analysis, initial investigation, so they can kind of see if the cluster's running, if it's crashed, but they can't actually perform any actions on it.
We call them firefighters.
Firefighters.
They're the ones that put out the fires. Something's gone wrong, they put out the fire.
All right, firefighters. Now, I'm going to quickly talk about the last one before the fourth one. The last one is our self-service user or our application administrator. So application administrator is this end user role we were talking about, and this is the person that's scoped to a cloud. So again, Fabric administrator, they touch hardware. They are scoped to host groups. Application administrators, they touch the VMs and the end services. They are scoped to clouds. So this is very likely to come up, figuring out, hey, which type of admin are you going to use based on whether they're touching infrastructure or just the VMs and services. So again, with our application admin, this is the person we're going to scope down and say, hey, John the developer, you only have access to this cloud. And John the developer doesn't understand those underlying hardware components within the cloud. Now going back a step to item number 4, the tenant administrator. This user role is new in 2012 SP1, and this administrator simply has control of creating other application administrators. So think of it as a manager of these cloud users only. So this tenant administrator, they can't change the infrastructure. All they can do is go and create new user roles for other end users. So you can maybe think of this as just your access or your security admin. So let's go and actually do this. Jump back to our demo system here. We see we have our Contoso Cloud, and we're now going to go into settings and take a look at our different user roles. So here is the default built-in user role for our administrator. Let's go and create a new one for our self-service user. So I'm going to call this my dev user. And we'll call this, well, this will be for John the developer. Here we get to specify whether they have access to host groups, access to clouds, read-only access, or account creation access. And in this case, we're going to go create the self-service application administrator. So they're just scoped to our clouds. Under members, we then go into Active Directory and get to list either individual members or even groups. So in this case, I'm going to go add my developer user, developer@contoso.com.
Now, there was a question actually came up as should you use groups or users when you do this?
Either. Do you have any best practices or guidances on that?
The best practice for me is you always use groups. Whenever you assign permission, you always do it to group because users
can come
tend
and go,
to change, right? They tend to come and go. Groups do not. Users, you delete them, recreate them, the SIDs change, permissions go away, groups do not. So it's
good point.
It's always a best practice, do things with groups when you're assigning individual permissions.
Yep, great point though. So we add our members, we then have the scope. So this will list all of the different clouds that are available. We only have the single cloud. Then here's where we get to define our quotas at both the role level, so all members of this user role. So this is basically, all the developers that have access to this cloud, and then the individual member. So going back to the previous example, this is my developer team, and this individual one is for John the developer. So within my team, let's go and say they can create up to 50 VMs across the whole team. And then for the individual user role, John can only create up to 10 VMs. VM networks have the ability to provide network access to these VMs. That's our virtual network. Then we get to provide access to which resources. So this is scoping down the individual templates. So in this case, oh, let's just give them access to all of our templates. Actually, you know what? Let's not give them access to the individual profiles. Let's just go and give them access. Oh, let me just cancel out, that'll be easier. Let me just actually give them access to the entire VMs themselves. And so when our end user looks at the library, they're only going to see these templates, but they're not going to see any of the profiles. And then this is where you actually get to specify permissions. So this is where you can do things such as checkpoints, preventing, or enabling. Now in this case, what we're going to do here is we're going to say they can have every permission, except they cannot deploy a brand new VM. But they can deploy a VM from a template. So this basically means that this individual user, so you know what, I'm going to not let them do checkpoints either. We'll follow that best practice here. But for our templates here, they could deploy a VM, but only from a template. They can't deploy a VM from scratch. Add run as accounts. So basically, for this end user, when they go and perform a task, they'll have access to these particular run as accounts.
Now, when you say they have access to the account, they're allowed to use the account. They don't have access to the details of the account.
Correct. Yes. Good.
So they don't have access to the
clarification.
username and the password. They're just able to say, "Hey, I need to do a task, and this is the account to use," and they rely on the Fabric administrator to have pre-configured that account to be valid and have access.
Great point. Yep. And then we get to view the script. So we hit view script here. We see everything that's been assigned, everything that's been created. We'll click finish. And this will then go and configure this user role. Now, next thing we're going to do here is we're actually going to go and log in with this user role and make sure that this secure access actually worked.
So while you're getting that kind of started, one of the things to kind of help sort of glue this stuff together, and again, we still see occasional questions on the networking. When you define things like logical networks and you define physical networks, you connect them all together. At the end of the day, when a user goes to create a VM in a cloud, they're only going to see the objects that you expose. So the user that's creating this VM has utterly no knowledge of things like where the wires go and how the cards are connected and what the port profiles are. All they see is, I want to make a VM. I've got 3 profiles I can use to make a VM, and I can only connect it to Contoso network. So you might have 100 of these things, but they're only going to see the ones that you expose to the cloud. So they go new VM, big VM, Contoso network, go. And BMM figures the rest out based on the rules you've layered under the scene. So this is an example of what the user's actually going to see right here.
Great point. Yep. Now, what I'm going to do here now is open a new VMM connection. But notice here, I'm going to switch over to my developer role. We'll click connect, and then it's going to open a new instance. So look at the original instance in the upper left corner. You can see that I'm running this under the administrator context, giving me full access to anything within VMM. What we're going to see when this second instance opens is you're going to see that this is scoped to our dev user. And now if you take a look at our clouds, we see that things have changed a little here. Where is the fabric? You notice something different on the workspace?
It's irrelevant.
Entirely removed. We don't want them to care about the fabric.
You don't
That's
care.
the key thing.
You're administering the cloud. Why do you care about the fabric? So get rid of it.
So remember, as you're thinking about this conceptually, break apart our infrastructure guys, which are based on host group management, away from our end user guys, which are based on cloud management. And again, end user, the people like our DBA, our developer. So if we go down to our library as well, let's take a look at the profiles that we have access to. Look at that, only the default profiles exist. Yep. All of those other ones that we said they didn't have access to,
not there.
Can't see them. So let's go and try to deploy a new VM using this user role. So I go create a new virtual machine. And in this case, I'm not going to use a template. Now, if you remember, one of the settings we said was they can only deploy a VM from a template. So I'm going to go and try to deploy a brand new VM. Let's see what happens. Call this our VM06. Make this a generation 1 VM. Click next. Go through this process. Where do I want to go place this? I want to go deploy this to a cloud. Uh-oh, there's a problem. We are having trouble here because guess what? You cannot go and deploy this to a cloud using a using a brand new virtual machine. This capacity profile will not let you deploy the new VM. So let's step back a little, retest this, and actually go and create one from a template. So I'll go deploy my web
If you
template.
just go back in there for a second, notice how few things are in that screen as compared to previously. All you see are the templates you have access to, which are, I see something about SQL and something VM because it's way over there. And I can't
That's
quite
right.
read.
That's our SQL backend and our web front end.
Your screen's
template.
12 feet from where I'm sitting, so I can't quite read it.
So you select our VM, could go through the process, and then it will go let us deploy, assuming that all those other metrics match. Uh-oh, I've gone over our memory. So this is something where I just don't have enough free memory in the cloud. It was scoped down. My mistake on the configuration here. But what I'm trying to prove to you here is around the security and access, right? We said you only see these resources. That's all they saw. We said you can only deploy from a template. That's all we're going to let them do. Well, with that, we're going to go and wrap up this module. We're going to be taking a 10-minute break before we then return to look at all these other System Center components.